Welcome to this explainer. If you've ever completely dreaded that classic, well, it works on my machine excuse, you are absolutely in the right place. Today, we're moving beyond single containers and building a robust, multi-service application baseline using Docker Compose. Whether you're a novice just getting your feet wet or a seasoned developer looking to really streamline your workflow, we've got you covered.
Okay, so here's our ultimate goal for today. We are going to transform your workflow from managing these single one-off containers to launching a fully coordinated app stack with just one single magical command. Literally, we want to get you to a point where your entire application baseline, your backend, your frontend, the database, the whole shebang spins up effortlessly and is immediately ready for AI-assisted feature work.
Here is our agenda for today. We're going to hit the setup, move right into the foundations, and then decode the blueprint. After that, we'll walk through the build, do a little inspection, and finally get to the payoff.
All right, Section 1, the setup. Let's talk about shifting your paradigm.
Now, there is a stark contrast between a single-purpose experiment and a full application lifecycle. When you just need a quick UI bring-up or a standalone tool, Docker Run is fantastic. It's great. You interact at the container level, you see those container IDs frequently, but for a real multi-service application stack, we're upgrading to Docker Compose. This allows us to declare our infrastructure in one unified YAML file, giving us beautifully repeatable startup and stop behaviors. So a reliable rule of thumb here, single tool means Docker Run, while an entire application stack means Docker Compose. It's a real game changer.
Moving right along to Section 2, the foundations. Let's cover our core Docker concepts.
Before we can orchestrate multiple services, we need to make sure we're speaking the exact same language. So first up, the Docker image. Think of this as your unchangeable packaged blueprint. It contains absolutely everything needed to run your application. The code itself, the runtime environment, all your system dependencies. It is completely frozen in time and ready to be deployed anywhere.
Next, the Docker container. This is simply that blueprint brought to life as an active, running instance. If the image is the architectural drawing, while the container is the physical house that's actually been built and is currently being lived in.
Now enter the Docker volume. I love this one. This is basically your immortal hard drive. This is what keeps your database data completely safe, even when the containers themselves are destroyed. Without a Docker volume, pulling down a container would completely wipe out all your database records. But with it, your data survives container recreation seamlessly.
Finally, we've got port mapping, which bridges the digital gap. By mapping host port 5173 to container port 80, you open a direct pipeline. This allows you to access the isolated container directly from your local browser. It literally routes the traffic from your machine straight into the application's internal doorway.
Okay, let's put all those concepts together into our three-tier stack mental model. Imagine clicking a button on your Bootstrap frontend, which lives locally at port 5173. That simple click triggers a JavaScript call to the Django API backend. The backend processes the request and securely reaches down into the PostgreSQL database. And the true beauty here is that this backend-to-database communication happens entirely within Docker's own internal, isolated network. It is completely shielded from the outside world.
All right, Section 3, the blueprint. Let's decode Docker Compose.
The absolute crucial point to remember here is that Compose is declarative. You simply describe the desired state in a single YAML file, and Docker handles all the heavy lifting of making it a reality. You don't have to write some brittle 50-line bash script that breaks if you look at it wrong. You just declare the final state you want, and Compose creates or updates the resources to perfectly match your request. Let's actually break down the anatomy of this blueprint. The build or image keys tell Docker exactly where to find the source code. Actually, scratch that. It's more like telling it whether it's building locally from a Docker file or pulling a pre-built image like Postgres 16. Then, depends on, creates a startup sequence, so your backend doesn't completely panic trying to connect before the database even wakes up. We use ports to handle the networking from your machine, volumes to secure that immortal data we just talked about, and NV file to act as a secure vault for passing in your runtime variables. It's essentially the DNA of your entire environment.
Section 4, the build. Let's do a step-by-step startout.
Theory is fantastic, but watching this stack spring to life is even better. Following these sequential steps is how we go from 0 to a highly satisfying HTTP 200 response. First, you prepare your .env file with your specific local variables. Second, you issue the command to start the stack. Third, you verify the status of the containers to make sure your database, backend, and frontend are happily running. And finally, you hit the backend Health API to confirm it returns a JSON response letting you know everything is perfectly okay.
Moving on to Section 5, the inspection. Time to fix some common beginner pitfalls.
Even experienced developers face monsters in the multi-service unknown. When things go wrong, don't panic. A bind error on port 5432 usually just means you left a local Postgres instance running into background on your machine. Just kill that conflicting process. If you change your code but don't see the updates, you likely need to force a rebuild of the image. And crucially, if your database data completely vanishes, you probably accidentally used the -v flag when bringing down the stack, which wipes your volumes clean. Consider yourself warned. Avoid using that -v flag unless you intentionally want a full reset.
I highly recommend making this practical newbie checklist your literal morning ritual before you write a single line of code. Check your Docker daemon to make sure the client and server are running. Verify your .env file exists. Ensure your build command succeeds, and that running Docker Compose PS shows all your containers as actively up. Finally, ping your front-end and back-end endpoints to ensure they return a 200 status. Running through this saves hours of ghost hunting later in the day. Trust me on this one.
And finally, Section 6, the payoff, powering AI-assisted development.
So why do we go through all this meticulous setup? Well, a rock-solid single-command Docker baseline is essentially your ultimate secret weapon. It gives you a perfectly reproducible sandbox for prompt-driven AI coding. Because you have clear back-end and front-end contract boundaries and much faster debugging thanks to deterministic service startup, you eliminate the "it works on my machine" problem entirely. You are building a practical, stable sandbox that is ready to be loaded up with complex future features like RAG and AI agents without your environment crumbling beneath you.
I want to leave you with this final provocative question to ponder as you prepare to launch and experiment with your own robust development sandbox. Consider the speed and confidence you gain when your entire infrastructure is codified and reliably repeatable. How does this stack actually support your future AI-assisted feature delivery? How will you use this baseline to accelerate your next big build? Thank you so much for joining me for this explainer, and have fun orchestrating your new multi-service stack.